Good morning. I am Mr. A. Anand, Assistant Professor, Rogini College of Engineering and Technology, Department of Civil Engineering, CE 8602, Structural Analysis 2. So here discuss about influence line for member forces in pin jointed plane frames. So this is the influence line for member forces in pin jointed plane frames. Forces in the members of truss. Based on the loaded conditions on the members of trusses experience torsions and compressions, the diagonal members are in tension and vertical members are in compression. When the unit load is transmitted along the bottom chord member, the influence line diagrams will be drawn for different chord members. This is the diagram for trusses frame. The top chord members. Consider a top chord members ui, u2. Let the support reactions be Ra and Rb. When a unit load is taken, three conditions are taken into consideration, which are the follows. This is the truss, and find the sections. By using the sections, you want to find the influence lines. Reversal of stresses. In certain long stresses, the web members can develop either tension or compression depending upon the position of live loads. This tendency to change the nature of stresses is called reversals of stresses. So example, there is a problem. Draw the influence line diagram for forces in the number of warmed trusses as shown below. So this is the long truss. In this they are marking the dotted lines for finding the influence lines. Solution. First, this is the diagram for inclined sections 60 degree, 4 meter at AB, and for vertical 4 sine 60 degree. So there is PU2 U3 is equal to ml square ml2 divided by 3.404, that is compression, is equal to 1 by 3.464 b 8 into 12 divided by 20 is equal to 1.386 under point L2. So this is the diagram. So 1.386. An influence line for the force in member L1 L2 for F1 L1 L2. So F L1 L2 is equal to mu2 divided by height. F L1 L2 is equal to mu2 divided by 3.464 tension. When the load is acting on point A, Rb is equal to 0. So mu and F L1 L2 is equal to 0. Substitute the value for m2 in equation 2. F L1 L2 is equal to 1 by 3.464 into 1 divided by 5 into 14. F L1 L2 is equal to 0.808 in tension. When the load is acting on point 1.2, then Ra is equal to 1 into 12 divided by 20 is equal to 3 divided by 5. Mu is equal to Ra into 6. So Mu is equal to 3 divided by 5 into 6. And here substituting the value of Mu in equation 2, Fl1 L2 is equal to mu2 divided by 3.464 is equal to 1 by 3.464 into 3 by 5 into 6. Here the Fl1 F2 is equal to 1.3039 tension. And this is the influence line for the truss, that is 0.808 and 1.039. And next, the influence line for FU2L2. So already we have finished FU1L1 L2, and here FU2L2 is equal to shear force L1 L2 cos cosecant theta is equal to S shear force L1 L2 cosecant 60 degree is equal to Fu2 L2 is equal to 1.155 shear force L1 L2. When the load is acting on point A, Ra is equal to 1. Shear force L1 L2 and Fu L2 is equal to 0. When the load is acting on point load L1, Fu2 L2 is equal to cosecant theta into m divided by n. is equal to cosecant 60 degree into 1 divided by 5. Shear force L1, L2 and Fu2, L2 is equal to 0. So this is the influence line diagram for the truss. That is left side 0.230 and right side 0.6928. And next influence line for Fu2, L1. Fu2, L2 is equal to shear force L1, L2. Cosecant theta is equal to shear force L1, L2. Cosecant 60 is equal to 1.155 shear force L1, L2. When the load is acting on point L1, the Fu2 L1 is equal to tensile and F2 L1 is equal to compression. And this is the influence diagram for this truss. 0.231 at the top and bottom 0.693. The plus is tension and minus will be a compression. So these are this. Thank you.